All right, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar coming up. I am so excited about this, and we've got some very, very smart people on this webinar. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for any of our speakers, please don't wait, don't hesitate. Just use your question and answer tab and submit your question, and we will try to get to as many as we can near the end of today's webinar. We also have an interactive chat feature on this interface, so please, we implore you, please use it. We want this to be as interactive as possible, so feel free to chat out your questions, comments, whatever you want to share with us. And then finally, at the end of today's webinar, we will be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is using modern DevOps practices to become a digital innovation factory. Our speakers today are Jim Mercer, who's the Research Director, DevOps and DevSecOps at IDC. Nancy Gehring, who is the Research Director of Future of Digital Innovation at IDC. And Baruch Sadagursky, who is the Head of Developer Relations at JFrog. Welcome to you all. Thank you so much for joining me today. I am so excited to have this webinar with you. Nancy, I know you are going to be kicking off the presentation, so I'm going to put myself on mute, take myself off camera, and let you get right to it.
Great. Well, thank you. Thank you, everyone. Great. Hopefully you can all see my screen. I'm Nancy Gehring, again, a research director here at IDC, and Jim Mercer and I are going to talk to you today about digital innovation. And at IDC, we think of digital innovation in terms of software innovation. So software-centric products and services that are innovative and potentially disruptive for the enterprises that build them. And when we talk about software innovation, we think about enabling it by putting some strategic and tactical thought into planning, sourcing, developing, and distributing. So these are 4 really key functions that require good strategic approaches in order to do software innovation. And so during today's webinar, we're going to talk to you about each of these 4 areas. We'll define them, tell you what we mean when we're talking about planning, sourcing, developing, and distributing, and show you a little bit of research that backs up what we're talking about, and also give you some recommendations so that you can begin to think strategically about each of these areas. And with that, I'll hand off to Jim, who's going to talk sort of big picture about why you should be interested, why it's important to build software innovation capacity.
So thanks, Nancy. Certainly the gold rush of digital innovation is fully in motion, and our recent pandemic has only added fuel to that fire, such that IDC projects by the close of 2022, 65% of the global GDP will be digitalized. And why? Because the economy has changed dramatically. And digital-first organizations will be delivering 8 times the revenue growth and twice the margins of those who are left behind. So as such, software development is now a strategic part of any enterprise. And IDC survey data supports this trend, as we're seeing software development becoming the core enabling part of the modern business. In fact, when we asked about the role of software development in support of the business, top responses were how software development increased the competitiveness of the business and how it helped to differentiate the products and services in the marketplace.
Yeah, so I think those data points I think are really interesting. They make it very clear why it's important to think about digital innovation. So let me dive into talking about how you can build this software innovation capacity in your organization. And I'm going to start with the topic of planning. So when we talk about planning, we're talking about more than just project planning. Project planning is important, but there's some ongoing functions and some higher level functions that are really important. So, for instance, you really require a strong collaboration between business and tech leaders. So when you're doing product planning and product development, technology should be part of those discussions. And in addition, you need to put some investment into setting and tracking KPIs. So put some work into getting the right people together to define what success looks like, what are the important KPIs to your organization, then track those KPIs, make sure that your initiatives are performing the way you want them to, and then actually take action. So there are, I talk to a lot of organizations that set KPIs, but don't have a really good process for making sure the right people are tracking the performance of their software-based products against those KPIs, and then actually doing something based on what you're learning, right? Making some small or large tweaks, possibly killing a feature, killing a project if it's not doing what you hoped it would do, right? But the planning function is also tactical, right? So you have to make some tactical decisions around architecture. Do you want a microservices-based architecture? You have to make some tactical decisions around what languages you want to use, what frameworks you want to use. We also think about the build versus buy discussion as part of planning. So as you're building a new application, an application that might be customer facing, are there some software components that you can buy, some commercial software that might make up part of your completed application, or does everything have to be written totally from scratch? So those are some of the things we think about when we're advising people to put some strategic thought into this planning function.
So Nancy, good point about the build versus buy, because really over the years, the economics of the classic build versus buy of business applications has really shifted further toward the build side. And the risk of developing a business application incrementally using DevOps and altering the application regularly based upon user feedback is often lower than buying a commercial off-the-shelf solution that probably provides limited opportunities for customization of business logic and can leave you kind of at the will of the application vendor when you need new functionality added for your business. And certainly there are some exceptions to this situation, such as where there's well-defined standards, like accounting or ERP. But where we need to apply, critical business logic, build is often becoming the better option. And in today's modern, digitally competitive economic climate, it's critical that you are setting yourself up to be a software development-driven business that is laser focused on creating capabilities and services that meet the needs of the business and your end customers. And that's not usually done by deploying commercial off-the-shelf cookie cutter business application solutions. So further collaboration between IT and DevOps is vital. When we asked who from the C-suite is signing off on digital transformation initiatives, the number one response was the CEO, him or herself. This is really telling just how important these digital initiatives are to the current and future survival of the modern business.
Yeah, and with that, we'll just offer a couple of recommendations if you're thinking about further developing your capacity around the planning function. What we would recommend is to keep in mind that planning is an ongoing function. This isn't just something you sit down and you do once. So for instance, as I was talking about earlier in terms of using KPIs, use those to inform your decisions on an ongoing basis. This is something that you need to do continually. Also think about what kinds of technologies and processes you should put in place up front that might give you more flexibility in the future. And I think one example of where that's really important is when you begin to think about distribution. So how you're going to share or distribute some of the software that you're building internally. Are there things that you should put in place, processes, tools that make it easier for you to deploy your software at the edge or even internally so that you can reuse some of the software that you've built in the future? Or, do you want to take an API-centric approach so that you can make it easier for partners or customers to integrate with what you've built? So thinking about some of those decisions in the future can give you better options as you go down the road and want to build on the software-driven product or service that you've created. And then, think about, as Jim was talking about, think a lot about the types of modern technology and development tools that can have an impact on this build versus buy equation, because some of the available tools might tip you towards building versus buying and maybe give you more of an opportunity to differentiate. Jim, is there anything you'd add here?
Yeah, that modern tooling comment makes a lot of sense, but I do want to add one additional thing. It's kind of like, while we see the C-suite recognizes the importance of digital initiatives, there can be this tendency to want to keep them engaged along the way. Well, transparency and communication are certainly important and essential. Don't make the mistake of having your C-level leadership kind of act as a gate that can stall innovation and will most certainly impact your software development velocity. So you need to remove the friction from your DevOps pipelines. So you certainly don't want to be adding, unneeded friction to the software development lifecycle.
Yeah, it's a balance, isn't it? Because on one hand, you want those senior executives engaged because that can allow you to build the software that you're hoping to build, right? It can open doors in terms of other functions in the business, but it can also serve as a gate, like Jim was saying. So it's kind of a delicate balance. With that, I'll move on to the second topic we want to talk about, and that is sourcing. And today, we're going to talk about sourcing from the perspective of modern apps being increasingly heterogeneous, and probably more so than ever before. So when we talk to enterprises who are building software-driven products and services, those products they have open source components, they have custom code, they might have some commercial proprietary software, they might have some commercial software that they've customized using no code or low code approaches. The app might have some reused code or functions that the business has built for a different app or, in a different group in the business. And you might have a mix of languages and technologies, right? Particularly as organizations are increasingly using microservices-based architectures, they very often have a mix of languages within a single application. So this is great, right? This is part of the reason that applications are increasingly heterogeneous is because it allows an organization to choose pieces of code that are already developed rather than have to create 100% from scratch every time. But there's certainly some challenges with this. And just to sort of dive into the open source topic for a minute, open source is becoming increasingly popular, right? It's always been popular, but we were really surprised by this data point here. So we asked developers to think about the applications that they had developed over the past year and to say what proportion of the application code is proprietary versus open source. And they said 44% of the code was open source. So this is, nearly half. So if you're just looking at open source when you're thinking about heterogeneous applications, it's becoming a growing portion of applications that enterprises are building.
Yeah, so Nancy, kind of based upon the results from our recent IDC DevOps survey, there's really a lot of different reasons why DevOps teams are increasingly using open source software. Some 35% said they prefer open source software because it's customizable versus their traditional commercial off-the-shelf solutions. More than half indicated it allows them to build applications and services at a lower cost. And then another 54% stated that open source software helps them to be more innovative, allowing for more opportunities to kind of quickly try new things with the ability to, fail fast if they need to pivot. And open source software helps DevOps teams move faster by improving developer productivity and keeping developers from wasting their time writing software from scratch when it's already available and proven in an open source software community. However, I guess the question is, how do you keep track of all this open source software? So this will kind of help us understand why it's important to track our open source software lineage. So let's look at what software composition analysis is and why it's so important. And we can start with our application. Okay, so it's likely our application is using quite a few open source software components based upon, we saw the survey data. But it's not quite that simple because the open source software we use directly also uses open source software. And that is also using open source software. So this hierarchy of embedded open source software components is often referred to as a software bill of material, or an SBOM. So, let's think, what if open source software component 3A on the far left has a vulnerability? Then our application also has that vulnerability. So we've all learned about the use of contact tracing, thanks to COVID. And software composition analysis is all about contact tracing for open source software. Think like COVID, contact tracing. It's not necessarily who you interact with, but who they have interacted with. Because if they've interacted with somebody who has the virus, likely if you interact with them, you have the virus, right? So software composition analysis provides us visibility into this software bill of material, as well as vulnerability detection, licensing challenges, and so forth. In fact, some organizations are beginning to request a software bill of material from ecosystem partners as part of their technical due diligence. So let's take a look at some recommendations. Well, first, it's critical that you have a handle on your open source software usage and your exposure to vulnerabilities. Ensure you're using a software composition analysis solution to track that SBOM. It's also essential that you understand all and any licensing limitations of embedded components. For example, a copyleft or reciprocal open source software license requires that any software product embedding that open source software component, even if it's just a few lines of code, needs to make its entire source code available for free, along with the rights to modify and distribute it. So this is clearly a serious problem for any application that's available for commercial usage or where there's proprietary code and business logic within the application. Again, this is where a software composition analysis solution can help DevOps teams with this problem. Next, set up an internal curated open source software repository. This to kind of ensure that the developers are taking authorized or vetted copies of components. And, it provides another level of tracking the various versions of the open source software components being used in your applications. Nancy, anything you want to add here?
Yeah, two things. One is I just want to comment that I love your contact tracing analogy because I think it just really hits home for people. It's really the perfect analogy when you start thinking about how deep, your layers of open source software might go in an application. But I also just want to emphasize, we've been talking a lot about open source software specifically and how some of these approaches apply to people that are using a lot of open source. But again, this is more broadly applicable to the fact that, like I was talking about at the very beginning, the modern application is very heterogeneous, and it's not just because of open source software, right? You might be using software that you developed internally for another project that's not really technically open source software. You might have commercial components that make up your ultimate application. So all of these things that Jim's been talking about are relevant beyond open source and relevant in today's increasingly heterogeneous application.
Great.
Okay, with that, I will move on to our third topic, which is around the development function. And so really what we're going to emphasize here is the increasing interest that enterprises are taking in cloud native technologies and approaches. And this is really driven by increasing demands to be agile, right? And that in turn is driven by an interest in meeting this rapid feedback imperative. So enterprises that we talk to increasingly want to make sure that they understand how their end users are reacting and using their software-driven products. So collect that feedback and then apply it, right? So quickly make changes to your software in order to respond to this feedback that you're getting from your end users. And so that's really driving the adoption of new technologies. It's driving interest in microservices architecture, right? Makes it easier to update a piece of your application. It's driving interest in automation and orchestration tools. It's driving interest in containers, which in a similar way makes it easier in a lot of cases to iterate and develop on an application that you've already built. It's also driving the adoption of DevSecOps practices. So, people have been talking about DevSecOps for many years, but it's really more recently that some best practices are emerging and organizations are more broadly embracing DevSecOps practices. Again, helps to ensure that your apps are secure, but do that in a very efficient way. And it's, I'd argue that chaos engineering, this is an approach that maybe some of the more forward-thinking organizations are taking to do testing and production in a way that's going to improve the performance and also potentially the security of an application. So these are all the kinds of approaches that we're increasingly seeing enterprises take interest in. And we're definitely seeing this grow over time. So this was a survey question that we asked last year. We asked people what describes the scale at which your organization does or plans to do cloud native app development now, so in 2020, and then in 2 years' time, so by next year. And what these results show is that increasingly organizations are expecting to embrace cloud native approaches outside of, an incubator or a test environment, and increasingly more likely to be embracing cloud native as a well-governed approach across the entire organization.
So, of course, Nancy, hand in hand with cloud native is the adoption of DevOps and DevOps methodologies. And I would state that you really can't do cloud native without doing DevOps, right? And along with that would be container technologies. And these both of these are key towards being a digital innovator. Our IDC data shows that DevOps increases competitiveness, innovation, and perhaps most importantly, it delivers a high degree of business value. We're definitely seeing the more mature DevOps teams proactively engaging and working with their business counterparts. It's really that continuation of shift left, right? We're shifting left, right into the business. And as DevOps teams look to improve their velocity and to accelerate application development, containers are proving to be vital towards providing the agility required by modern digital innovators. So as Nancy kind of mentioned as we went into this section, we simply cannot overlook security. As the application landscape continues to increase, bad actors are increasingly attacking applications, looking for insecure code and known vulnerabilities that might be in some of that open source or somewhere else in our application. And this means that digital innovators need to adopt DevSecOps and DevSecOps practices. And we see the primary drivers are improving the security posture of applications by catching security issues earlier in the software development lifecycle, where it's easier to fix them and avoids these dangerous production security issues being exploited by a hacker. This requires security with automation, so we can do our security due diligence without reducing our velocity. If you're not presently using or adopting DevSecOps, probably the time to get started would be now.
Yeah, and so let me just touch on a few recommendations, and we've touched on a few as we've been talking through this topic. But one is definitely encourage you to stay on top of cloud native technologies and approaches, right? They continue to evolve. There's more and more tooling and technologies that organizations are adopting, which again really helps improve agility and velocity. Definitely think more about DevSecOps because, like I said, it's a topic that's been around for quite a while, but there's really increasingly some best practices emerging that can really help you embrace this idea and ensure that you are developing in a secure way while still being able to be agile and move quickly. And then in terms of containers, it's pretty clear that containers also support this interest in agility. I would just say, think about some of the tooling that's out there. There's sort of more types of tools available that can help with managing containers, because certainly as you scale up, you also approach a level of complexity that creates a new set of challenges. Anything you would add there, Jim?
Yeah, Nancy, we've been talking a lot about open source software security, which is critical. But you simply cannot overlook the importance of container security as well. And this requires certainly, firstly, that you use a trusted, full-featured container registry to preserve the sanctity of your containers and enable fast application delivery and deployment. But also, you should be scanning your containers for vulnerabilities and using container security software throughout the life cycle to kind of mitigate those container threat vectors. I guess I'd say at a minimum, look to use some of the open source software tools as well that can help, such as like an OpenSCAP or a Docker bench. But I guess my point, Nancy, is let's not overlook the container security as well.
Yep, good point. Okay, so I will move on to our fourth and final topic that we want to touch on today, and that is the topic of distribution. This is one that I'm maybe most interested in at the moment, possibly because I think it's the least mature. I think there's a lot of really interesting things going on here, a lot of creative experimentation that's pretty fun and cool. So when we're talking about distribute, we're thinking about ways that you publish and distribute the software that you build. So there's some very, well understood mechanisms here, right? Build a mobile app, publish it in an app store. But there's so much interesting stuff going on right now. So, there's more and more organizations are thinking about edge deployments and the benefits that they can get by deploying software to the edge. There's IoT deployments that are happening increasingly. There's making API access to your software as a way of essentially distributing access, making it easier for your customers or your partners to integrate with what you've built. There's open sourcing the software that you've built. So enterprises are open sourcing some of the software that they've built as a way to build community and further encourage development of something that they've begun building. There's building developer portals as a way to essentially distribute internally built software, right? So whether that's to allow API access or otherwise engage with developers. There's internal distribution that's happening. Again, I've touched on this a couple times where enterprises are trying to share and reuse some code that they've built internally if it supports a function that's very easy to be reused in another application or a service. We're seeing businesses create marketplaces and do a lot of innovative types of partnerships. And we're definitely expecting this to grow. So this was a really interesting survey question we asked, where we asked developers what proportion of their applications are made available to other organizations for reuse or modification via APIs, open sourcing, a developer portal, or other methods. And we asked respondents to answer that question in terms of what they're doing now and what they're planning in 2 years. And what you can see here is that respondents are expecting to make a greater portion of their applications externally available within the next 2 years. So this is certainly a trend that we expect to grow. And this, I think, is super interesting. We did some really interesting research where we looked at the Global 2000 at what they're doing in terms of developer engagement. And in a lot of cases, this was manifested by a developer website, so company.developer.com. And frankly, I'm pretty surprised by this. So amongst the Global 2000, almost 65% of them have some sort of developer engagement program. But what's super interesting when you look at this is as you go up, so to the top global 100 companies in the world, 80% of them have some sort of developer engagement process. And so this tells us that the biggest companies, the most advanced companies, are engaging with developers. They're figuring out mechanisms and ways to share the software and the applications that they've built internally with a broader developer community.
So Nancy, that developer ecosystem data is pretty cool, actually. It's surprising how many companies actually are building these ecosystems. And as we see these developer ecosystems grow, more and more, we're seeing DevOps teams being tasked with distributing out to non-traditional locations. The days of deploying all your software updates to your nicely climate-controlled raised floor data center, those days are coming to fruition. Just look at some of the deployment targets in our survey data on the slide. Edge, IoT, temporarily air-gapped systems, such as autonomous vehicles, wearables, AR, VR, virtual reality devices, consumer electronics, enterprise IoT, robotics, drones, and so on. The need to deploy software regularly to targets that are behind perhaps slow or unreliable networks is increasing. We are not in a secured, safe data center space anymore. It's a whole new paradigm that's happening. Our traditional deployment and software repositories were not designed to handle these types of challenges. So how can we verify that all the software got to where it's supposed to be successfully and securely? And how do you scale it? In fact, IDC projects that half of new infrastructure will be deployed to the edge by 2023. This will lead to 7 million new edge locations and 38 billion new things by the close of 2021. And 80% of these new edge workloads will use containers and microservices to improve their digital resiliency. So in terms of some recommendations, digital innovators will be tasked with running applications closer to the customer. I mean, we saw some of those targets, right? To deliver an optimal digital experience. And it's critical that software artifacts are securely and consistently distributed to all internal, external stakeholders, end users, you name it. And as you distribute software to the edge, the security of the artifacts needs to be a top priority as well as some level of validation about the software was received and deployed correctly. So digital innovators should be seeking out solutions that can help in this new distribution paradigm, and they can scale across networks by mitigating bandwidth bottlenecks throughout the delivery cycle. And with massively distributed software architectures, the need for high levels of software velocity, the frequent changes, this only compounds that problem. And the need for delivering to the edge in a repeatable and scalable manner. So it's a whole new world, Nancy. Any thoughts?
Yeah, I'll just sort of underline the whole new world point, because this is really new. This is really emerging stuff. And I would encourage you, if you're thinking about some of these more creative methods for opening up your software, sharing it, or distributing it to new ways, begin to think about ways that you can automate some of those processes, so that this may be the first time you're doing it, but it hopefully won't be the last. So think about ways you can automate in ways that will, ensure that you're doing things securely in the best way possible. And by the same token, definitely look for tools that are emerging, because there are some new tools that are emerging to make some of this stuff easier, to help you automate this kind of thing, and to ensure that there's governance around the way that you are sharing your software externally. So there is a lot going on. It's very new. It's pretty exciting. Look for what's out there that can help you, because you don't necessarily need to reinvent the wheel every time you do it.
Yeah, great point about the automation. I mean, that's key for making it repeatable, right?
Yeah.
So Baruch, do you have some insights for us here?
Thank you very much, Jim. Thank you very much, Nancy. That was an awesome explanation of the 4 steps. And now I would like to take this theory to a more practical level and show you the examples of some of the steps being implemented using the JFrog platform. So think about software delivery as a factory in which you have a pipeline going all the way from source to production. And this is what the JFrog platform gives you. It gives you a complete coverage of everything from sourcing through develop to distribution. And we do it with the JFrog platform and the tools which are within it, such as JFrog Artifactory, JFrog X-Ray, JFrog Distribution, and the JFrog Edges. And I'm going to take you through the entire journey, step by step, in our live demo. So we will see how the developers source for the components and then use JFrog Artifactory as the repository for caching those components and using JFrog X-Ray to make sure that the components that they pick are both secure and also allowed from governance perspective. And then we're going to talk about distribute, which is kind of a solved problem, but still obviously very, very important and very centric to what every developer does. JFrog Artifactory as the target for the deployments, JFrog X-Ray for security, for compliance, JFrog Pipelines as a tool for continuous integration and continuous delivery, and then JFrog CLI to be able to plug the same capabilities into any CI CD component. And then the most exciting, I would say, for us is the distribution part, which is definitely the next frontier, the next focus for both the methodologies and the tools. There are many different ways of distribution. Some of them you don't even think about as distribution. For example, you have development teams in different locations. Take an artifact and move them from one location to another in order to make it available as dependencies for other teams is distribution. And then downloadable software, stuff that people download to their computers and run. We want to make sure that these downloads are as fast as possible, secure, and covered with correct licensing and everything. This is done through Content Delivery Network, the CDN. And then stuff like distributing to the edge, cloud computing, fog computing. This is where JFrog Artifactory Edge comes into play. It's a server to which we distribute and from which it goes the last mile, and then going into this last mile into the cluster with P2P distribution. So this is the JFrog platform that covers everything that Nancy and Jim spoke about. And now let me actually show you the flow, the source, develop, distribute. Before we start with the developer actually doing sourcing, we have some preparations to make, and we will start with the JFrog platform. And here it is. You can see here the overview of different components. And before we are going to use JFrog Artifactory for our components and JFrog X-Ray for our components, we need to prepare them. If we go to Artifactory, we need to make sure that we set up the right repositories. And you can see how JFrog supports 26 different types, and more are coming. That, for example, the support for Rust crates is around the corner. We are very excited about that. So you pick the technology that your developers use. Now, if you want in an ops hat, pun intended, and then boom, the right repositories are created. That will be both the proxy for the dependencies that they're sourcing and the target for the stuff that they're going to distribute. We go and we set up policies for compliance, and then we say, hey, we want to make sure that we take care of security, and we create rules. For example, I want the high severity violation. If there is a high severity security issue in some of the components, do such and such. What you can do? Well, it's a range. It's a range between a lot of freedom for developers to being productive, but also compromising some of the hermetic security that you can tight, all the way to, on the other side, making it very, very tight, but also hurting the productivity of developers when you require, for example, to approve each and every new dependency they source in front, and this approval can take time. So a couple of levels of security that you can see right here. Very light security, just notify me, tell me if there is a problem, but then we go ahead and tighten it, and we say, well, block the distribution. Let them run with it, let them build what they want, but don't distribute it to production. Or you can go tighter and you can say, fail the build. Let them do whatever they like in their personal sandboxes, their computers, but once it hits the CI, block it. Or you can go even tighter and say, you know what? Block downloads. If there is a security issue, just don't allow anyone to even download it. And this is obviously, you can play with it with different levels of security. You can set up rules, more constraining rules for high severity and less constraining rules, more lax rules for low severity. You can also decide by project. You can say, hey, this is an experimental project. It probably won't get to production like immediately. Let the developers run with it. Or this is like highly visible, very important project. I want to be more tightened with it. So for our example, what we are going to set is we will allow downloads. We will allow downloads because I want to show you how the process looks like of sourcing from the developer's perspective. And now we have our developer that is doing the sources. Now let's get the sourcing. Let's get to the source, develop, distribute. And the sourcing is basically Googling it, right? This is where it starts. The developer will search for the right dependency, for the right component, based on their knowledge, based on their experience. And let's say for some bizarre reason, a developer decided that the dependency that they want to use is struts. I mean, this is a weird decision in 2021, but this is what they managed to source. Now they add struts and then they run build on their local machine. The struts dependency is going to be resolved because you remember we allow download, but immediately we will get a warning in our IDE that we have a problem with this dependency. You can see how the top issue severity is high, everything is crimson red, and basically this is where we say to developer, hey, stop right here. You can go ahead and kind of build with it, right? Because you can commit to the source control, but since it has a high severity issue, you really shouldn't. Now, just to remind you, we will still be able to stop it from getting into the CI or fail the build and obviously prevent it from going to production, but this level of decisions we leave for the developers. This is our range between how strict we want to be with our security. Now, let's say they either go with it or don't, they write more code, they commit everything to source control, and the next thing that happens will obviously be the build. Now, the build is done in continuous integration, and continuous integration tools are obviously plenty. Here, I will show you kind of a combined example. So this is JFrog pipelines, and you can see here in our example, we have like a lot of pipelines, different pipelines that go in and out in all sorts of combinations. The one that I want to show you is, let's look at this one, for example. So here we have a classical three-step CI, right? So we build a component, and then we push it to a registry, which is Artifactory, and then we promote it from one repository to another. Obviously, there are some steps meeting, like testing and everything, but this is a simplified view. What's interesting here are those little gears that we have in between different steps. Those gears are the reliance of a metadata that we gather through the build to make decisions down the road. What do I mean by that? This metadata is what we call the build info. And the build info, those are the bill of materials of the builds. They are collected by the CI server throughout the build. And you can see here, I will show you another example here. Let's look at this one, for example. You can see how the build collected all the possible metadata, which module was built, and then which files are in this module as artifacts, which dependencies that we used to build this artifact. All the environment variables are collected, so whatever was the real deal when this artifact was created, we saved it and we know exactly what's going on. And also on top of that, obviously X-ray checks. And the X-ray checks, you can see here the high severity, the low severity, and everything else. I'm going to show you another example of how X-ray scans the data in a sec. You can compare between builds. You can say, I want to see how this build differs from another build in terms of artifacts, dependencies, and environment variables. And you can see the promotion of this build throughout your pipeline. This one was promoted from development to staging, and you can see the entire history one and one. Now you ask, well, how it is connected? What's the magic? Obviously, if you use our pipelines, we take care of collecting the build info for you. But even if you don't, we have plenty of integrations with other CI servers, and our JFrog CLI allows the same level of metadata collection in any CI process, even bunch of bash scripts, because you will run the operations of getting the dependencies and then uploading the artifacts, running the build through JFrog CLI that will make sure to collect everything for you. In the end of the day, it's just a JSON, which is queryable by what we call an artifactory query language, and you can base your decisions on this, on all this information. And I promised you that I will show you a nice example of the X-ray scanning of the build, the one in which we decide should we fail it or not. Let me look at this one, for example. So here you see the same modules that were created, and here is our X-ray data. We see a lot of vulnerabilities. Let's look at this one. You can see how X-ray, once this metadata hit Artifactory and the artifacts hit Artifactory, X-ray knew how to analyze this build, find in one of the modules Docker image, find a layer inside this Docker image, find something that looks like a Java artifact, and then find its dependencies and all the problems in them. In this example, 5 layers down. And this is obviously the second level of defense. You remember the first was we won't even allow downloads. This is the second level of defense, which we say, hey, this is where we stop it. And then we go into distribution. And as I mentioned, distribution comes in plenty of ways. One of the distribution scenarios is we just say, hey, we set up a replication. We set up a replication between different servers. And then we can say, okay, from the main Java platform distribution, we want to distribute to 1, 2, 3, whatever we like. And the artifacts will appear there for the other developers to pick it up. If we want to distribute using Content Delivery Network, this is also very easy. For Content Delivery Network, we will just set up a new repository, local repository, and then we will just say, hey, that's a checkbox. That's our production repository, and we have a checkbox that say, make sure you're capable of distributing through Content Delivery Network. Now, the third type of distribution is actually using a JFrog distribution within the platform. And this is done by creating yet another set of metadata and artifacts that we call a release bundle. And a release bundle is a set of artifacts, which is usually a set of builds that you take your application, let's say it's a microservices application, combine them together into one release bundle, wrap it in a metadata, sign it with your security key, and then send it over to the edge nodes in which this application will be installed. And here's an example. And you can see here how in this application, we gathered 13 different microservices, which are 13 different builds, and kind of build one bundle out of it. And how it is done? Again, by using the Artifactory query language. And you can see here a bunch of queries that go ahead and pick the right files because they were part of those builds. Once we did that, again, another level of security and compliance defense. Here again, we have our X-ray data that we can go ahead and look at what happens. And we can say, okay, this is also a good place to stop. It still is not in production. So you can see here, okay, this is our release bundle. It contains a Docker image. It contains a layer, which contains a dependency. And this is actually its transitive dependency that has a high severity, security, vulnerability. Again, it's not too late to stop. And then once we done that, and everything looks good, not like this, but let's assume it, we can see how they are actually being distributed to two different, there are two distributions, two different edge nodes that then can go ahead and go into the edge and being distributed in the edge. So with that, this is more or less the entire picture in our limited time in 15 minutes, and you can see how we went from all the way from sourcing, finding the artifacts, verifying them in the IDE, and then build CI again with control, with metadata, with decisions based on this metadata, and then distribution internal, different teams, external for CDN, and in the end of the day, edge by using JFrog edges to distribute to the edge computing. With that, Jim, Nancy, back to you with questions.
Yeah. So we do have a couple questions, and unfortunately, we're about 4 minutes to the top of the hour, so we're only going to be able to get to one or two of them. But let's go ahead and dive into the ones we do have. Let's see. First question here. What is the biggest challenge we hear for DevOps adoption?
Do you want me to take that one? So I mean, I'll just say from my own experience, talking to customers at IDC, it's still culture. It's still definitely one of the big stumbling blocks. Culture and leadership, or full leadership buy-in, not just lip service to adopting DevOps and Agile. Although I think from my experience, particularly over 2020, and we talked a little bit about this during the presentation, I think that's softened a bit as the business has come to understand the value that DevOps provides and how strategic it should be. I think there's other things, like monolithic apps that make it difficult for teams to, kind of release frequently, cloud adoption, and certainly, things such as repeatable, streamlined DevOps pipelines that, you've got a DevOps tool chain that actually works and is well integrated, and, there's not a lot of friction in the process. It will help with DevOps scalability and adoption.
All right, great. Let's see. I think we may have time for one more question here. Okay, how can organizations move fast and release faster with all of the security checks that they also need to do?
Yeah, I will take that real shortly, and my answer will be stop validating the releases. Validating each and every release, it's exactly the bottleneck that stands between you and releasing faster. Instead, make sure that your pipeline is doing the work for you. Invest in the pipeline automation, shift left, make sure that you do any type of checks that you care. And it's not only security and compliance, it's also the quality. It's also the penetration tests. It's also performance. The more you automate into your pipeline, the less you will have remaining for your manual checks, which are your bottlenecks.
All right, great. Well, we are about 2 minutes to the top of the hour. So that is all the time that we have for the question and answer period. I do want to thank everybody who did submit questions. If we didn't get to your question, please know that the folks at JFrog will be getting a copy of all the questions that came in, and I'm sure they'll be more than happy to follow up with you offline to get your question answered. Also, a quick reminder that today's event has been recorded, so if you missed any or all of the event, you will have the opportunity to access it later on. Following the webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website, so you can go look for it there. Just go to DevOps.com/webinars and look in the on-demand section. It should be right there waiting for you. Okay, real quick before we close things out, want to do that drawing for the $425 Amazon gift cards. So without further ado, today's winners are Eric H. Congratulations, Eric. Juan P. Congratulations, Juan. Ian H. Congratulations, Ian. And finally, Anila M. Congratulations, Anila. We'll be following up with all four of you via email to get your Amazon gift card over to you. So please check your inbox. If you don't see anything in your inbox, please check your spam folder. Jim, Nancy, Baruch, please, thank you very much for a great presentation. Always a pleasure to have you all on the webinars. Lots of good information imparted. So we do appreciate your insight and your expertise.
Thank you.
Thank you.
Thank you very much.
Take care.
I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Please stay safe.